Hello everyone, my name is Rodolfo Marcos. I am Google Cloud Certified Data Engineer, and today I'll show you how you can create a simple but powerful pipeline in Google Cloud using Cloud Functions, BigQuery, and Cloud Storage. First of all, imagine that we have a situation where we want to ingest employee information in one BigQuery table. This employee information comes through CSV files, and this CSV file has 5 columns: employee ID, employee name, birth date, occupation, and gender. Suppose every time we load a file in Cloud Storage, we want to insert new records on the table and also update information for existing ones. For example, if the employee with ID 5, Paul, changed his occupation from student to engineer, we want to reflect this change in our final table. Before we start developing in Google Cloud, let's take a look on the pipeline overview. In the left side here, we have a Cloud Storage bucket where we are going to place our employees' CSV files. Each time an employee CSV file is placed here, a Cloud function will trigger, getting the contents of the file and loading into a raw employee table, which is the step 2. Third, a deduplication SQL comes into play that will get the information from the raw employee table and saves the result on the employee final table. This deduplication SQL is responsible to merge the raw employee with the final employee table, doing any kind of updates on existing employees that change some column or inserting new employees. Now, the first thing you need to do is going to Cloud Storage, and now we are going to create 2 buckets. One that will serve for input files and other for temporary jobs that BigQuery uses. The first one, let's call it input sample pipeline. You can set it as multi-region US, set as default, and then hit create. Make sure to enforce public access prevention. Okay, now let's create our second bucket. Let's call it temp sample pipeline. You can follow with the defaults here as well. Just keep sure to choose the same region. Okay, now that we have our 2 buckets created, let's go through Cloud Functions and start pasting the code that will do the process. If you go to the article, you can see that we have the snippets for the 3 files that we want in our Cloud Function: main.py, merge.sql, and the requirements.txt. You just need to go to Cloud Functions and paste it there. And we need also to replace the values for line 10 and 11 of main.py. So I'll hit create function. I will call it sample pipeline CF. We need the environment as second generation. I will add an event.rc trigger. Here in event.rc trigger, we can choose Google Cloud events to start our trigger. Here we will choose event provider to Cloud Storage. The event will be object.finalized, which is when an object is created under Google Cloud bucket. And now we choose our bucket as input sample pipeline, not a temporary. And say trigger. In the runtime, I will change the timeout to the maximum, which is 540 seconds. And then I'll hit next. Now here, let's change our runtime to Python 3.11. And now I will create a merge.sql file there. And I will just copy and paste the values from the code. Here in the requirements.txt file, we have the Google Cloud BigQuery library set fixed to 3.9.0. I encourage you to use fixed versions to not have problems when a library is updated and you have to review all your code. It's always a good practice to make your libraries updated, but when you want to update, do it manually. Change the entry point to main. Now that we have our three files here, let's replace the variables for stage table ID and table ID. First, you need to put your GCP project in the first part. You can get it from the URL. And now you have to create your BigQuery dataset. I already have one named sample pipeline. You can create your own dataset and just get the name. Okay, now we are done. Every file is pasted here and we replaced the variables. Just a note here is that in line 13, this file pattern, we are going to only process files that follows these regex, which is sample underscore and the date in format of year, month, and day. Why you have this there? Because currently, this cloud function will trigger for every file that is placed under the bucket, even the ones we don't want to process. So it's a good practice to filter which ones we are going to process. In this case, we are using the regex. If the file does not match this regex, the cloud function will stop. It will take some time for the cloud function to be deployed. If it's the first time you're doing it and they are using Event30C for the first time, you may have problems here because you have to wait some time before it works properly. You just need to wait some minutes and then try again to deploy your function. Everything's set up, our function is ready, let's test it. First of all, I will open the cloud function and go through the logs section here. Here we can see all the steps the cloud function is doing and all the prints that we have in the code will be shown here. Suppose now we are going to ingest two files in sequence. The first file is sample 2023-0401, which has a list of 20 employees, okay? And second, after this is ingested, the second file we are going to ingest is this one with only 2 records. The second one has a change on an already existing employee, John, which in the first file is data engineer, and in the second file it's a professor. And also we are inserting here a new employee, Marcelo, with ID 22. Let's place these 2 files in the bucket in sequence and wait for each of them to process. Inside our input sample pipeline bucket, let's place the first file. As we can see here in the logs, it says that a file named sample underscore 2023-0401 was loaded in this bucket and 20 rows was loaded. If we check on BigQuery, we should see the table there. Okay, we have the employee table there with the 20 records that was loaded. It worked as we expected. Let's do it for the second file. Okay, so now our second file is processed and let's look for the change. So now we want that John is now a professor and a new record for Marcelo is created there with employee ID 22. If we go through our employee table and hit refresh, we can see that now John is a professor and we have a new record, Marcelo, with ID 22. So it worked as we expected. I just want to point it out that this pipeline is our starting point for you that want to ingest some files in Google Cloud. It actually can handle a lot of data in big files if you import it, And you can also play with the SQL part for doing the process you want, converting column types. Feel free to explore there. The idea is to have a starting point or to resolve a specific problem on ingesting data. If you want something more powerful, you may consider using Cloud Composer with Dataflow or Cloud Composer with Dataproc, or maybe using data prep for ingestion. But this solution is basic, but it's powerful and it's cheaper compared to other solutions that we can have in Google Cloud. I hope it will help you on what you need, and thanks for watching.